In this video, we're going to talk about the different angle relationships that exist. We're going to talk about adjacent angles, which are two angles that are next to each other, and that means that they share a ray in common. Take a look at angle 1 and angle 2 in this top left diagram over here. Notice how they are right next to each other. They are touching. They share a ray in common, so they are adjacent angles. We also have vertical angles. Vertical angles look like this letter X over here. They're formed when two lines intersect. So anytime you got that letter X, you got two intersecting lines. Vertical angles are formed. Vertical angles are the non-adjacent angles that are formed by intersecting lines. So this angle and this angle would not be vertical angles because they are adjacent. They are touching. They are right next to each other. This angle and this angle would not be vertical angles because they're adjacent. They're right next to each other. They are touching. But this angle and this angle, they actually are opposite from each other. They are not adjacent. They are not touching. So this would be an example of vertical angles, as would these two angles over here. And the really nice thing about vertical angles is that they are always congruent. So anytime you see intersecting lines, anytime you see vertical angles, we know that they are congruent to each other. Angle 1 and angle 2 are congruent vertical angles. Angle 3 and angle 4 are congruent vertical angles. Complementary angles are any two angles that add up to 90 degrees. So together, when you put them together, they make a 90-degree right angle. They could be adjacent, like the complementary angles that you see in this picture, they're touching, or they could be non-adjacent. So they could also be two separate angles that together make 90 degrees, and they would still be complementary. They don't have to be adjacent. Supplementary angles are two angles that when you add them together, they make 180 degrees. They make a straight line, a straight angle. These two angles that you see here are adjacent and supplementary. They're touching and supplementary, but just like with complementary angles, we could very well have two angles that are non-adjacent that are also supplementary. This example I just drew here would also be an example of supplementary angles, even though they are not adjacent. We actually have a very special term for when angles are both supplementary and adjacent, and we say that they form a linear pair. Linear pairs are adjacent and supplementary angles. So if you take a look at the examples that are here, the first pair is adjacent, they're touching, and they're supplementary. They add to 180, so we say they form a linear pair. Same thing with the second picture, adjacent and supplementary, so we say that they form a linear pair. We're going to take a look at some examples that use these angle relationships, that use supplementary, complementary, and vertical angle relationships. So I'm taking a look over here, and I notice that the 50-degree angle and the one next to it, when I put it together, I get a straight line. I get 180 degrees. So 180 degrees minus 50 degrees is 130. And I'm going to make this look more like a 50 and not like a 60. And that gives us 130 degrees. So the missing angle measurement here is 130 degrees. Here, we can use supplementary angle relationships, or we could recognize that this 30-degree angle is vertical to this angle over here. So angle FEG is vertical to angle IEH. And then we know that angle IEH is also 30 degrees. And then using our supplementary angle relationships, any two angles right next to each other here form a straight line, a straight angle, make 180 degrees. So 180 minus 30 gives us 150 degrees. And then we know that this angle is vertical to this angle, so they are congruent. So if this one was 150 degrees, if angle IEF is 150 degrees, so is angle HEG, it is also 150 degrees. Now we're going to move on to some Regents questions on these angle relationships. So if you take a look at this first example, we're told that we have intersecting lines. Line A intersects line B. And anytime that I have intersecting lines, I know that vertical angles are formed. And remember, vertical angles are always congruent. So these two angles here are vertical angles, and these two angles here are vertical angles. They're the ones that are across from each other, the non-adjacent ones, when we have intersecting lines. So we can make an equation that says one vertical angle, with x plus 5, is equal to the other vertical angle, which is 2x minus 5. From here, we can simply use inverse operations to solve for x. 2x minus x is x, 1x, or just x for short, plus 5 to both sides. And we have x is equal to 10. And it is just asking us for the x value, not to plug back in, so our x value here is 10. The second example is telling us that we have supplementary angles. And that means that when you put the two angles together, they sum to 180 degrees. And we also know that the angles are in a special ratio, a 2:7 ratio. And we're looking for the measurement of the smaller angle. Whenever you have a ratio, you can express it algebraically so that the 2 part could be represented as 2x, and the 7 part could be represented as 7x. So now if you keep in mind that two supplementary angles need to add to make 180 degrees, we can make an equation that says that. If you take the angle that's 2x and you add it with the angle that's 7x, it should make 180 degrees because these are supplementary angles. 2x plus 7x is 9x. And then from here, we'll just subtract divide by 9. And we have x is equal to 20. Now be careful here because it says the smaller angle. So the smaller angle is the 2x angle, and the larger angle is the 7x angle. X is none of the angles. So 20 is just the x value. It's not any of the angle measurements. I actually am going to have to plug in here in order to find the smaller angle, which is 40 degrees. So be careful there. Make sure that you read the questions carefully and that you make sure if it's looking for the x value or if it's looking for you to take your x value and plug back in to get your final answer. Over here, we have another question that involves supplementary angles, and it uses a ratio as well. So once again, supplementary means 180 degrees. They add to make 180 degrees. I would recommend that you pause the video, and based on what we did in the last one, you try your best to represent the ratio algebraically to come up with your equation and to find the measurement of the smaller angle. I'm going to continue on this video, but you should definitely pause. Remember, we can represent the 3 part of the ratio as 3x and the 6 part as 6x. So I can make an equation that says the 3x angle and the 6x angle together need to make 180 degrees because supplementary angles add to 180 degrees. 3x plus 6x is 9x. And we have x is equal to 20. And just like before, we have to pay attention to what the question's asking. The smaller angle is the 3x angle. The larger angle is the 6x angle. So 20 doesn't represent any of the angles. We have to actually plug in to find the measurement of the smaller angle. So I'm going to plug in 3 times 20 is 60 degrees. So that is the measurement of the smaller angle. For any of these questions that we do, I highly recommend that you pause the video, try it out yourself, and then you unpause the video so that you can watch and see if you got the correct answer or what you might have done incorrectly. So please keep that in mind for all of the questions. You should definitely pause the video first. Here we have AB and CD. They're both line segments that intersect at point E. always draw yourself a picture when there's not a picture that's provided, because otherwise you might think it's one angle relationship, but it's really something different. It's always best to draw a diagram so you can really see what's going on. The measure of angle AEC is 6x plus 20. AEC, that's this angle right here. E's in the middle, so it's going to be at E, so that's 6x plus 20, this angle right here. And the measure of angle DEB is 10x. DEB, 10x. So notice how those are vertical angles. They're formed by intersecting lines and they're opposite from each other. They're non-adjacent. So vertical angles are always congruent. So I can make an equation that says the 6x plus 20 angle is equal to the 10x angle. And from here I can solve. I'm going to subtract 6x from both sides. And then I'm going to divide both sides by 4. And I find that my x value is 5. Let me make that look nicer because that's a really ugly 5. And my x value is 5. It is asking what is the value of x, so 5 is our final answer here. It does not ask us to plug back in and find the measurement of the vertical angles. In the next question, it tells us that we have two complementary angles. Complementary angles are angles that add to 90 degrees. And we're given expressions that represent these two complementary angles. And we need to find the x value. So we don't need to plug back in at the end. We are just looking for the x value. I can make an equation that says if I put the 3x plus 15 angle together with the 2x minus 10 angle, it will make 90 degrees. And once again, that's because when you add two complementary angles together, they make 90 degrees. From here, I'm going to combine my like terms. I have 3x and 2x. That makes 5x. I also have 15 and negative 10. If I put 15 and negative 10 together, that makes 5. And then from here, I can subtract 5 from both sides. And my last step is going to be to divide both sides of the equation by 5. So 85 divided by 5 is 17. And we are just looking for the value of x, so that is our answer. In the next example, we have intersecting lines AB and CD. So already I know that we have vertical angles that are formed. And it gives us the measurement of angle AEC as 4x minus 40 and angle BED as being x plus 50. And these expressions are on the vertical angles, and vertical angles are always congruent. So we could make an equation that says the 4x minus 40 angle is equal to the x plus 50 angle. And once again, that's because they are vertical angles. We can subtract x from both sides. And then I can add 40 to both sides. And then my last step is dividing by 3. And I have x is equal to 30. It does want us to plug back in because the question's asking find the number of degrees in angle AEC. So this is angle AEC, and it wouldn't matter which one you plugged into because vertical angles are always congruent. So I'm going to plug into 4x minus 40. So 4 times 30 minus 40. That's 120 minus 40. And that is 80 degrees. These will be our last two examples for this video. Let me just delete all those marks over there. This will be our last two examples for the video. So we're told that two angles are complementary. And once again, that means that they add to 90 degrees when you put them together. The measure of one angle is 15 more than twice the other. So there's two angles. There's the first angle and there's the second angle. And I don't know what any of the angles are, so I'm going to call one x because I don't know what it is. And then the second angle is 15 more than twice the first angle. So twice the first angle would be 2 times x, and 15 more than that would be plus 15. So I could make an equation that says the first angle taken together with the second angle makes 90 because they are complementary. So this part represents the first angle, and this part represents the second angle. And when you add them together, you get 90 degrees because they are complementary. X plus 2x is 3x. When I subtract 15, I get 75 on the right-hand side. And then finally, dividing both sides by 3. And I'm just running out of space here. So I didn't write the divided by 3, but we're dividing both sides by 3. And that gives me 25. I'm going to double check the question. And it is not asking for the x value. It's asking for the measure of the smaller angle. But wait, this was the first angle and this was the second angle. So the smaller angle is represented as x. So 25 is x. So that is the measurement of the smaller angle. In the next one, we have a diagram that has intersecting lines. So I know vertical angles are formed. I know angle 1 and angle 2 are congruent vertical angles. And I know angle 3 and angle 4 are congruent vertical angles. And I see that in the question, they give me 2 expressions. They give me the expression for angle 3, and they give me the expression for angle 2. And it might be tempting not to fill in the diagram and to just set them equal to each other because there are vertical angles in the diagram. But remember, there are also supplementary relationships here. Angle 1 and angle 3 are supplementary to each other. Angle 3 and angle 2, angle 4 and angle 2, angle 1 and angle 4. Any 2 angles next to each other make 180 degrees in this diagram. So what we should do is we should put the measurements in the correct spots in the diagram and see what we're actually working with. So angle 3 is 6t plus 30, and angle 2 is 8t minus 60. So notice how these measurements are not on the vertical angles. They are on 2 angles that have a supplementary relationship. Ultimately, we do need to find the measurement of angle 4. The question is asking for the measurement of angle 4. And angle 4 is vertical to angle 3. So after we set up an equation to find the t-value, then we can plug the t-value in to angle 3 to find out the congruent measure of angle 4, which it's vertical to. But right now, with the expressions that we have for angle 3 and angle 2, since they are supplementary angles, we're going to set up an equation that says if we put angle 3 together with angle 2, we make 180 degrees. And I'm going to combine my like terms, 8t and 6t. That's 14t. 30 and negative 60 is negative 30. I'm going to add 30 to both sides. And our last step is to divide by 14. So I'm going to just do 210 divided by 14. And that gives me 15. So now to find the measurement of angle 4, I'm going to use its vertical angle, angle 3. So I'm going to sub back in 6 times 15 plus 30. And I'm going to use my calculator. I'm going to do 6 times 15. And I got 90 plus 30. And I got 120 degrees. So 120 degrees. And that means the angle that's vertical to angle 3, which is congruent to it, will also be 120 degrees. So I'm going to write that down here a little clearer. The measure of angle 4 is 120 degrees.